As you prepare for the capstone, we're going to walk you through some key concepts so you can get ready to work on that project. So in this screencast, we're going to demonstrate how to define and configure data models using Entity Framework Core. So the first thing I'm going to do here is set up the project structure. I've got a terminal window open, and I'm going to use the .NET command to create a new Blazor WASM project. I'm going to call it SkillSnap, and I'm going to use the hosted flag to set up a shared folder, a server folder, and a client folder. So I'm going to go ahead and run that. And that sets up my project. So I'm going to move to that folder. So we have our project open, and now we can get started on building this out. So the first thing I'm going to do is move to the shared project. I've got client, server, and shared. And I'm going to move to the shared project first and create a new folder called models. And then in that folder, I'm going to create a new file called portfolio user. And this is going to be a C# class. And then I'm going to create one called project. And then I'm going to create a final one called skill. So we've got three classes set up here that we're going to use throughout the project. We're going to use these classes in both the client and the server applications. But first we need to populate these with some code so that we can use them. These are just going to be class files that will create objects in the other components. So the first thing I'm going to populate is the portfolio user class. This is a class with some key value pairs. These are just properties that we're going to end up using. We don't have our project or skill set up yet, so these aren't resolving, but we've got our portfolio user with name, bio, and image, and then any projects and skills they've worked on. I put a namespace up here at the top, which will be important as we build out the client and the server. So I'm going to now create our project class, and I'm just going to paste that in. And similarly, we got our project object. We've got an ID, title, description, and image. And then we've got a foreign key set up, the property reference here above portfolio user ID as a foreign key, and that's pointing back to portfolio user here, and it's going to pull in that ID so that we've got a foreign key relationship between the portfolio user and our project, which will allow us to be able to pull in this data in our project class. And then the final class we want to set up is our skills class. At the top of the project class, I've got the system.componentModel.data annotations, and then the data annotation schema, which is what allows us to use these types of properties. I've also got a key here, indicating that's a key and required property here for title. And we can add those properties to these other items as well if we wanted to. These are going to be important when we use Entity Framework, so that Entity Framework knows how to build out the data model when we actually run that. So that's why we're adding all these items. All right, let's go to skill, and I'm going to paste that in. I've got data annotations and data annotation schema at the top. I've added my namespace. I've got key and required here. This is going to be our database key, and we need to make sure that we're using name. And then we do the same thing with a foreign key to portfolio users. So then we can use the skills and the projects in our portfolio user so that when we create this object, this entity, it will pull in any projects that users worked on and any skills that user has. All the classes are now built and everything's resolving, so now we have all the relationships set up for those classes. Okay, next I'm going to move over to my server project, and I'm going to create a new folder here called data. And this is where we're going to set up our Entity Framework context class so that we can actually use Entity Framework with these objects. And I'm going to create a file called SkillSnap context.cs. And then I'm going to put in my Entity Framework items into this class here. We've got our Entity Framework core, which I need to actually install because that's not available yet. And then we've got our DB context and our reference to portfolio users and projects and skills. So when we use Entity Framework to build out the data model, this is the class that will do that for us. So we do need to install some dependencies, so I'll do that real quick as well. So I'm going to add a couple of packages here. First, I'm going to open up a terminal window, and I'm going to run a .NET add package Microsoft.Entity Framework core. And that's because I'm not in the right item. I'm going to move to server. All right, now it should work. All right. And then I'm also going to add an item for SQLite. Now we've got our packages installed, and that should help us as we continue to work through the project. Okay, we've got all of our dependencies resolved, and now I'm going to move to the program.cs file so that I can register the skill snap context in that file so that we can actually use the entity framework items. So I'm going to move to program.cs, and then at the top of the file I'm going to put a couple of using statements so that we can use these libraries. I'm adding entity framework core and server.data. And I actually need to remove this. That's the wrong reference. Okay, so now we've got server.data, and then I'm going to add the builder item here. This will allow us to use the skill snap context in our application. Need to add one little item here. I need to add a semicolon, and then that should help everything resolve. I've got a use SQLite here problem. I can fix that in a moment. It's just a reference issue. But everything else is wired up, so we can use our skill snap server data model in this application. We're calling this skill snap context. We're setting our data source to skillsnap.db. This is a SQLite database. So when we run our entity framework model, it will create that database if we need it, and then wire everything up to our application. That's the first stage in getting this application to run. And now we can move on to the next phases where we're working with Blazor and using entity framework core. In this screencast, we're going to demonstrate how to build RESTful APIs using ASP.NET Core Web API. And we're continuing to prepare for the Capstone, so we're going to continue to build out the server side. I've got a Blazor Wasm application here with a client application, a server, and a shared application. And we're going to use all of these three apps together to make database calls and then display them in a Blazor front end. The first thing I'm going to do in this screencast is create API controllers in the server project. So we're already in the server project, and we've got a data context, skill snap, which is the name of our application, skill snap context. And we're going to continue to build out some controllers now so that we can make calls to those data models once we get everything wired up. So the first thing I'm going to do is create a controllers folder. And I don't think I have one. So yeah, I do have one. So I'm going to use this controllers folder that we already have. This came from the template, the weather forecast controller.cs. It's not going to bother anything to leave that in there. So we'll leave that in there. And then I'll create a new file called projectscontroller.cs. In this file, we're going to set up some routes for our API. This is the server project. This is essentially the API side of our application. And I'm going to create some routes. So I've got some libraries that I'm using. I'm using Entity Framework Core. I'm making a reference to the server.data folder that we've created. So that namespace is being pulled in. And then the skill snap shared models, which we created earlier. And so we're referencing that namespace as well. And now I've got an API controller set up here, and the route is API and then whatever name of the controller that we pass in based on how this is going to be set up. So we've got a class. It sets up the context item, which is the skill snap context that we created earlier. That's this file here, which is our DB context. So we're making a reference to that in this class. And this is our controller base that we're setting up here. We're setting up a read-only variable, and then we've got this method projects controller, which passes in that context. Our first route is the get route. This is an async task, and it's get projects. So what this is going to do is just grab all the projects from the data context that we passed in, and then return OK with the name of the projects. If this were a real-world application, we want to add some error handling here just because something could go wrong. This method doesn't account for that. But for this screencast, we're just going to set up a basic route that returns the projects once it gets it from the data context. The next is the post route, and here we're going to add a project, and we're grabbing the data from the body of the API call that we're making, and it's going to be put into the project class that we created in our models folder in shared. Because we have a shared project that we can reference from the client and the server, We only have to create those classes one time in shared, and then we can use them in both the client and the server as we need them. So the server is going to be the API side where we're making calls, and then we're going to pass that back to the client, which is a Blazor app, and then display that using Blazor controllers. So we add our project items to the database context using the project class. We save those changes, then we return the fact that we created that project with the project ID. We send that back to the calling function. So now we've got our first controller set up, and that allows us to interact with the application and the data. The next thing I'm going to do is enable cores for the Blazor client. This is just a security measure so that we can actually interact with our client without any security issues. So I'm going to go back to program.cs, and I'm going to add some cores items here under our builder services. So I'll go ahead and paste that in. I need to move this one under the app because the app object hasn't been created yet. We have our cores options set up here. We're using builder services add cores. The options are to add a policy to allow the client, and we're setting an origin. So for this application, as long as the client is making the API call from localhost 5001, then we'll allow any method and any header. This just prevents people from the outside from accessing our app in ways that we don't want it to. So now I can go ahead and put this here. And this is essentially the method that sends that allow client policy to the use cores method so that we can allow that policy through. All right, so now we've added cores to our application, which provides us with some security. And now we're going to create API services in the Blazor client. So now we're going to go over to the client app. I'm going to minimize these so we can see this a little bit more clearly. Here, I'm going to create a services folder and create some client-side services. And in the services folder, I'm going to create the class file called project service.cs. This is where we'll start adding some methods that we can use to interact with our shared folder in our server. Okay, we've got our using statement, which is skill snap shared models, and then we're just using a .NET library, system.net.http.json, so that we can pull the JSON data in. We've got a class called project service, and we create a read-only variable called _HTTP, which is an HTTP client object. And then we have our project service method passing in that HTTP client, and we're just setting that equal to HTTP. And then we've got a couple of async methods here. The first is get projects async. The second is add projects. We have a get and an add method. And you can see where we're using those routes that we created on the server side, API/projects. We're getting the list of projects from that API route, and then we're posting to that API route. So this is how we're starting to set up that interaction between the client and the server, and we do that in this class file. Okay, next I'm going to register the service in the Blazor client application on the program.cs file, so I'm going to switch to that. We're just going to add the scoped reference to the project service that we just created to that class file. Now I'm going to start creating some Blazor pages that we can use in our application. So I'm going to go to the pages folder, and I'm going to create a new page called projectlist.rager. In this file, we're going to start to set up some UI, some user interface items, as well as some components that we can interact with our application. We're injecting the project service that we created so that we can use the data that we're getting back from those calls. And then we just have some HTML, H3 with my projects. And then we list through all the projects, and we provide the project title and the project description that we've received from that project service when we make that call. And here's where we make that call in the code component. So we've got a private list of projects variable that we're going to fill when we make that call. We've got our async task on initialize async, which will run. So as soon as we hit this page in our application, then we're going to populate the projects variable here, which is again a list of project objects. And we're going to use that project's async in order to get that data back. So we're starting to build out the client side now, and the client side you can see is interacting with the shared application that we've created and the server application, and all of these three are working together to build that full stack environment that we need to build in order to use data, API, and client-side code. As we continue to prepare for the Capstone project, we need to work more on our client-side application. So in this screencast, we're going to demonstrate how to build and organize reusable Blazor components that we can use across pages. So we've got an application here with 3 essential parts. We've got a client, a server, and a shared application, and they all interact together. The server is essentially the API part of our application. The shared has shared components that we can use in terms of our data model. And then we've got a client side that's a Blazor application that will display the data that we're pulling. So what we're going to do now is create a reusable shared Blazor component. And we're going to do that by creating a new folder in our client application. So I'm going to call this shared, and it already exists. So we don't need to create it. So instead of creating it, we'll just use the one we have. Thank you, VS Code, for helping us out there. So what I'm going to do here is create a new file called profilecard.razor. And this profile card will contain components that we can use in other Razor files. So we only need to create it once, and then we can reuse it across different Razor pages. So I'm going to create this card. It has HTML here at the top. It's going to use the card class for styling, card body, etc. These styles haven't been created yet, but we can obviously add these as we need them. It's going to essentially have a UI that will create this card that has the name and the bio and the image URL from our shared class that we created for the portfolio user. In the code section of our Razor app, we have 3 parameters. We're using that parameter keyword, and we have a name, bio, and image URL. And that will obviously come from data that we're pulling from our API, which is in the server side, using the classes that we built on the shared side. So now this card we can reuse as we need to throughout the application. Now we're going to work on two-way binding with the app_bind keyword. I'm going to stay in the client, and I'm going to move to the pages folder, and I'm going to create a new page called add skill.razor. And in here, we're just going to, again, create another Razor component. Paste that code in. HTML at the top. We've got an input for a skill name and a skill level. We're telling the user that you're adding a new skill at this new level. So when this page renders, we're going to see that data being bound to those items within our paragraph as well as within our input items. So as the user adds the skill name, that will be bound to this data item. We can then use that to populate our database just by binding that to the objects that we care about. So here in our @code component, we create our 2 objects that we're using obviously up here, and we're binding those to these objects, and then we can pass that back to our data as we need it. Now the next thing we're going to do is connect the UI to the backend data. So now that we've got this object created with those bound properties, we can now send that back to the database as we need to. So I'm going to stay in pages. Now let's go back to our project list.razor file and take a look at that. Now I just want to point out again that we use this inject statement to inject the project service item and then load the project data when the page loads. So we've got this already wired up, and this is where we can start to use some of these components just by using the inject and the bind statements. Now we've created that profile card.razor component. Now we're going to actually use it as a reusable component in a page. So in the pages folder, I'm going to create a page called profile. Let me make sure I don't have that already. Profile.razor. In this profile Razor page, I'm going to use that reusable component that we created earlier. We've got now our profile page with the name. We're using the skillsnap.share.models, so there we're referencing our shared application again, and then referencing our shared namespace as well here within the client application. So we've got our profile card in the shared namespace, so we want to make sure that we're referencing that so we can actually use it. We've got our profile card objects. That's in a tag, so it looks like an HTML tag. We created that component, and now we can reference it as a tag set in our other Razor file. So we're using that profile card, and we're referencing the @user.name, which we set down here. We'll get to that in a moment. Bio @user.bio, and then user at user.profile image URL for our image URL property. We're passing that data to the profile card. That's the parent. This is the child. We're passing that data here, and then this gets rendered within these items once we load that profile page. In the code section, we create a profile user object, which again was defined in our shared application. And we provide a name, a bio, and then a profile image. And then we can render that card right here in this page. And we can use that profile card in any other page we want as well. That's what makes that profile card reusable. We create it once, and then we can use it across our application as we need to. So we're starting to build out our client side now, and we're getting more UI elements and more components. So we're getting ready to go on that. And now we can continue to start working on other elements of our application on the server and the shared aspects of our app. As we continue to prepare for the Capstone, we built out some components on our client side. We've got a shared application, and that shared application is allowing us to share objects across the server and the client. We built out some components of our server application. So in this screencast, we're going to demonstrate how to implement authentication using ASP.NET Identity. And we're going to do this in the server application. Open up the server application and then open up a terminal. I'm in the server app, so we're going to do some work here, and I want to make sure I'm in the right folder. The first thing we're going to do that we've already done actually is install Entity Framework Core. We've got a reference to Entity Framework Core and a reference to SQLite. Those are now installed. If you don't have those installed already, you'll want to use these commands. I'm not going to run them, but you want to add package Microsoft ASP.NET Core Identity Entity Framework Core and Microsoft.Entity Framework Core SQLite. And I do have to add the identity because we don't have that installed. So I'm going to add this one. We have Entity Framework Core installed, but we don't have the identity library for that. So I'm going to run this, and we're going to add that. That's added to our references. And this is in the CS proj file. We have all of our dependencies installed. The next thing we're going to do is configure the identity in the data context. For that, we're going to go to skillsnapcontext.cs, and we're going to update this a little bit. So we've got a reference to our Entity Framework Core and our skillsnap.shared models. I'm going to add two items to the top, the items that we just added, the identity items that we need. These are references to these libraries so that we can take advantage of some of the aspects of those libraries. So we've got our public class skillsnapcontext DB context. I'm going to add another class reference to application user. We're going to make this an identity user. So this is leveraging that identity library that we created a reference to earlier. So now we've got a class called application user, and it's of the type identity user. Now we can use that in our application. Instead of just calling these items without any identity involved, now we can leverage the identity features of ASP.NET Core. Now to use this, we need to change the type that we're referencing here in our SkillSnap context class. So right now it's just DB context, but we want to be able to use the identity DB context. So I'm going to use this reference, and we're going to pass in the object we just created, application user. All right, and I have a little typo here, so I'm going to fix that. So now we've got our SkillSnap context using identity for the DB context rather than just a general database class and database setup. We're actually going to be able to use identity with our application. In order to do that, we need to go back to program.cs and create a couple of more items here to enable identity within our application. So the first thing we need to do at the top of the file is use ASP.NET Core Identity as a library. Then we need to add a service. We're going to add our service builder.services, add identity. I'm going to put this below our cores option. And now we've got our builder services add identity. We're passing an application user and the identity role. And then we're going to add Entity Framework Store SkillSnap context. To apply the database changes using EF migrations, we actually have to apply this to the database. We would do that. Let me clear out the In the terminal window, we would use these commands. I'm not going to actually run this right now, but these are the .NET commands that we would use to add the identity features that we just put into our server classes to the database so that we would enforce the identity. We've added the identity objects to our application, but we actually haven't used them yet. We haven't done anything with them yet. So the next thing we're going to do is create a login and register models. And this is more classes that we can use with pages to create our login and register items. So I'm going to go back to the shared project and go to the models folder. And I'm going to create a new class called login model. I'm going to create another page called register model. Now, these are going to contain properties that we can use in order to be able to create a login page and a register page on our application. And this is going to enforce that identity using those objects that we just recently created in the server side. On the register model, we've got email, password, and confirm password. Those are fields then again that we would use within a page and a data model in order to set up user identity. And then when the user wants to log in, they would use that email and password as a part of the login page. And we're using this class, this model, to create those objects on the page. The next thing we're going to need to do is be able to use this from our server. So now we want to go back to our server application. So we've created the models in our shared folder. We haven't used them really in our client quite yet because we don't have any pages that use them. But we do need to provide the opportunity to call these objects that we just created and validate them against the database in our server. So we're going to go back to the controllers folder, and I'm going to create a new page called auth controller. That's CS. And we're going to put some code in here with some routes that will enable us to use those identity features that we're adding to our other projects. So there's a lot going on in here, but it's actually pretty simple. We've got our identity library, MVC, and our references to our SkillSnap server data namespace and our shared models namespace. And then we just have some routes here for dealing with our identity objects that we're creating. So we've got a public class auth controller. This is our controller base. We're setting up some variables. The user manager object, which we're passing in the application user here, and the sign-in manager object, which we're also passing in the application user. And we're creating these member variables using that little underscore symbol at the beginning so that we know that they're member variables. And then we create our auth controller method, and we're passing in our user manager with our application user, and then that's going to be referenced by user manager variable. And we're doing the same thing with the sign-in manager. So we're creating those member variables, and then when the class is created, we're referencing them. And you can imagine when we instantiate the class, we're using these properties to set our values for those two items. And then when we call auth controller, we pass them in. And then user manager is set to the user manager here, whatever we're passing in, and the same thing with sign-in manager. Then we have our routes. So we have a register route, and that has a register method. We're taking the data from the body of the API call, creating a register model object. We're taking the data from the body and putting that into the register model class that we created earlier. We're creating a new application user out of the data that we're getting from the body. Username equals model.email, email equals model.email. In this case, we're just using the email for both. And then we create our user manager. We use the create async method to pass in our user information as well as the password. If that call is successful, then we return an OK. Otherwise, we return a bad request. We're doing something similar for login. So now that the user's been created, we have a login method. Again, we're passing in the data, the password and email into that API call, and we're putting it in a login model object. And then we're calling the password sign-in async in our sign-in manager object, passing in the email and password. And then if that call, again, is successful, we're returning OK. Otherwise, we return unauthorized. We've got the identity system set up, and now we have a situation where we can actually use it in our API calls. So we've got the methodology now to make API calls to use some of those identity features. Now, the last thing we're going to do here is we're going to restrict access to sensitive endpoints by going back to the project's controller. We're going to put authorize in front of the methods that we want to make sure we want to protect. So we can use this authorized property. I'll do this for the get projects. We want to make sure that's protected. And let's suppose we want only administrators to be able to add new projects to this application. So we can set the authorized property and just set the rule to only admins can access this endpoint. So if you want to add a project, you have to be an admin. I'm not getting these authorized properties resolving because I don't have a using statement that I need. I'm going to go ahead and add one here at the top. I'm just going to copy this to make it a little easier. And I'm going to put this above this property. And Copilot's helping me here and giving me the authorization library as the library that I'll need to use this authorized property. So now we have authorize above get and authorize with a restricted role in admin. So now that we have identity built into our system, we can use that roles-based identity to protect certain endpoints so that only specific users can access them. So we're getting much closer now. We have a client-side application that we're building out. We have components of our server built out with security. We have cores so that our client-side can access it and only our client can access it. And now we've got identity and authorization starting to be built out into our application. We're getting a fuller model here of what we're after. And we have a full stack system coming together. We have shared components, a server side for our API calls, and then a client side, and the server side for the data as well, and then the client side to make those calls to the API and then render the data. As we prepare to work on the Capstone, we've got one more set of items we want to implement into our application. In this screencast, we're going to demonstrate how to apply caching and performance optimizations in .NET applications. So we've got our application made up of three parts here. We've got a client, which is going to display the data that makes API calls. It gets the data from the server side, which is this middle application here. And then we've got a shared application that contains our models and other shared components that we need across the three applications. In this screencast, we're going to look at how to implement caching. And the first thing we want to do is add in-memory caching to our application so that we can take advantage of cache data rather than having to go to the database every time. So I'm in the server application. I'm going to add all of these items to the server application. And I'm going to go into program.cs and add an add memory cache method call to our builder object. I'm just going to use builder.services, add memory cache. Now, once we've added it to the application setup in program.cs, now we can use it throughout our application. So to implement caching, I'm going to go to the project controller.cs file in our controllers folder, and this is where we're getting our list of projects and adding projects. These are the method calls for the API implementation that we put into our app. And I'm going to use iMemory cache here. The first thing I'm going to do is add another member variable called _cache, and that's going to be an iMemory cache object. So I'll put that into our projects controller class so we can use it across the methods that we have in this class. Now notice that I'm missing the iMemory cache reference, so I'm going to need to add that to the top of our file. I'm going to go up here and include a using statement. We're going to use the extensions.caching.memory library that iMemory cache resolves. So now we've got an iMemory cache variable called _cache that we can use throughout this application. In our projects controller method that instantiates the object, we're going to add a variable called _cache and set it to the cache variable that we pass into the method call. And I'm going to do that here. So I'm going to use iMemory cache and set it to that variable cache, and get a little bit of Copilot help there that filled that in for us. So now we're going to pass in both the context and the cache item into our method call when we instantiate the object, and then we set that member variable to the value that we pass into the method call. All right, now we're going to use this in our HTTP GET method. So I'm going to add a line of code within this get projects get method. I'm going to try to use the cache first. So when we try to get our projects, we're going to see if there's any variables or values in the cache first. So I'm going to look at the cache. If _cache, which is our member variable, try get value. And we're going to look for the name project list. So that's the name of the cache item that we're going to try to get. We're going to fill our projects variable with that value. So this is it doesn't exist, right? If we don't have the project list cache item implemented, then we're going to go ahead and pull it from the database. Otherwise, we're just going to grab our project list item from the cache. So now let me put a close brace here so that we put this in between our items. Notice I don't need this anymore because I'm passing in the project's value here. I'm passing that into our method call, the try get value. So I can just reference it inside the method. Now I'm going to set the cache. Once we've grabbed the project list from the database, I'm going to set the cache to that value. So next time we want to use the cache, when we assess whether the cache has the value with this if statement, we're actually setting the cache with the values that we've already pulled from the database. And then next time, this will resolve to true, and it will just return whatever's in the project list cache. So we set our cache options, new memory cache options, a sliding expiration of 5 minutes. It will use whatever's in the cache within a time span of 5 minutes. Otherwise, it will expire, and then we have to set the cache to project list to whatever is in the project's object, which we populate here. We use our cache options when we set that. We can use the cache to save calls to the database and those API calls, and that just improves performance as well as saves resources because we're not making those calls to the database as much. Now, the next thing we want to do is use EF Core query optimization. Right now, we're just grabbing whatever's in the project's objects and we're setting it to a list, and that's how we're populating our project's variable. But I'm going to update this slightly to include some optimizations. So I'm going to replace that line with this code. We're just optimizing this a little bit by using this include statement. Again, I need to take that very far out. We're using this .include, .asNoTracking, and .toListAsync. So the .toListAsync was already a part of our original call, but we're adding these items now. The asNoTracking reduces overhead by skipping change tracking. That allows us to only grab items if there's no changes to the data. Also, this include item ensures that related data like user profiles is loaded in a single call rather than in round trips. This allows us to make that call and to get the project's list more efficiently. Now, there's probably other optimizations we can do here. So I'm going to invoke Copilot at this point to help us improve this query, this EF query, to see if there's other things that we can do. So I've got Copilot integrated into VS Code, and I'm going to use the inline chat for this. Okay, and I'm going to just give it a simple query, optimize this EF Core query for speed, and let's see what it gives us back. All right, so it's provided some optimizations here. It's actually pulling in a lot of the data that we want from our project object, which makes it a little cleaner so that when we make that call, it's not having to look those items up. It's just a little bit more efficient. There's an error, but I'm going to accept this anyway. So Copilot didn't get this quite right. This is actually topic, and we're going to set that to title. I'm going to set this to title. When we look at the objects that we actually created, the title item is actually a part of that project class. Now when we go back to our controller, we can reference those objects. We have our optimizations, and we've used Copilot to help us improve the performance of this query by adding those items directly to the query itself. That improves the performance. There's one other thing that we want to do in our post statement. We're going to add one more optimization here. We want to make sure that we remove the cache if the data changes often. Now, this is a decision we'll have to make, but let's just suppose that it does. After it's posted and saved new items, we want to clear our cache so that the next user gets the project list from the database. It's getting all the items. We don't want them to get invalidated data. That's another optimization we can make just to ensure that users are getting the latest data. Now we've improved our API controllers by adding caching options to our project, and this enables our users to have improved performance, particularly for data sets that are heavily used. Caching can be a really important performance improvement. Obviously, you have to have the hardware to support it, as these items will take up memory, but this can improve the application's performance greatly. So now we've got all the components for our application in place. We've got our shared objects that we've created. We've got our client side with various pages that we can use to interact with the user. And then we've got our server side that has our API routes, as well as all the data items that we need to create the database and then interact with the database. We've also implemented security So we have an authorization controller and we've got identity management implemented into our server. So now we do have a full stack application that users can interact with. This is a very simple application for project management, but we've got the end-to-end system implemented and in place. In this activity, you'll scaffold the foundational layers of your full stack application. You'll structure your projects using scaffolding, build out your data layer with data modeling, connect a database with EF Core, and lay out a static front end with help from Microsoft Copilot. These 5 concepts lay the groundwork for everything that comes next. They'll help you structure a clean, connected application and get it ready for future features like logic, security, and performance optimization. You'll start by scaffolding your solution. Scaffolding is a technique used to quickly generate the foundational code and structure of an application, often including data models, services, or UI components. This means setting up your API and Blazor projects inside one organized structure. You'll also create a shared models project so your front end and back end speak the same language. This setup gives you a scalable foundation that supports shared logic and clean separation of concerns right from the start. Next, you'll build out your data models. Data models are structured representations of data entities that define the properties and relationships of the data used in an application. These define what your app will store and how the pieces relate. Portfolio users, projects, and skills will all become classes, and the relationships between them make up the data structure of your app. These models live in the shared project, so both your API and your Blazor front end can access and use the same data definitions. Once your models are in place, you'll configure Entity Framework Core to set up your database. This is the process of setting up and managing database connections and schema definitions, including defining a context class and applying migrations. You'll define a DB context to manage database connections, configure it to SQLite, and use migrations to create the schema that matches your models. This connects your app to real persistent storage and ensures the structure reflects your domain models. Next, you'll scaffold your front-end layout using Blazor components such as profile card, project list, and skill tags. These are static for now with no logic, but they'll give your app a visual framework to build out later. By using components, you make your UI modular, reusable, and easier to update when logic and data comes into play. Finally, you'll use Microsoft Copilot to help scaffold your code. Whether you're configuring a database or building UI components, Copilot can speed up routine tasks and help you stay focused on the big picture. You can use prompts to scaffold efficiently, fix repetitive code, or even generate missing pieces right when you need them. By the end of this activity, you'll have a well-structured, full-stack solution with models, a working database, and static components, all scaffolded and ready for future development. Let's get started. In this activity, you'll connect your Blazor front end to your web API. You'll create API controllers, configure communication between projects using cores, use dependency injection to access services, fetch and bind data to components, and get help from Microsoft Copilot along the way. These 5 concepts will help you pull your front end and back end together into a single connected system. With these tools in place, your project starts to behave like a real application. Let's walk through the key concepts. You'll start by setting up API controllers. These define the HTTP routes and logic used to handle client requests and send responses. You'll build get and post endpoints for projects and skills to serve and store data from the database. These routes form the backbone of your data flow, letting the front end read from and write to the back end. Next, you'll configure cores, a security feature that allows or restricts resources on a web server to be requested from another domain or origin. Cores allow secure cross-origin communication, so your front end can make API requests safely, even from a different origin. Without this, browsers will block the request since your API and your front end run on different ports. You'll also use dependency injection to pass services into your components. Dependency injection is a design pattern that allows services to be registered and then injected into components for reuse and separation of concerns. These services handle the HTTP requests that talk to your API. Each service acts as a translator between your component and the API, so your UI doesn't have to worry about request details. It keeps your code clean, modular, and testable. Once you've got your data, it needs to show up in the UI. That's where data binding comes in. Data binding is a mechanism in Blazor that connects data sources to the user interface, allowing dynamic content rendering and updates. You'll fetch data in your components and bind it directly to the layout using services like add-inject, @code, and lifestyle methods such as onInitialized async. With data binding in place, your UI updates automatically as new data comes in. And finally, you can use Microsoft Copilot to support the whole process. From writing a data service to catching an edge case in your form logic, Copilot offers helpful suggestions at each step. Copilot helps you scaffold quickly, spot missing logic, and improve the quality of your data flow without starting from scratch. By the end of this activity, your front end and API will be working together. You'll have a system that retrieves, displays, and sends data, laying the foundation for a truly dynamic portfolio app. Let's get started. In this activity, you'll secure your full stack application by adding authentication and role-based access. You'll configure ASP.NET Identity, build authentication endpoints, protect routes, and update the Blazor UI to respond to user roles. Microsoft Copilot will help you scaffold secure features and verify your logic. Let's take a look at the key concepts you'll use. These concepts control access across your app, so only the right users can view or change protected data. Together, they form a complete authentication and authorization system for your full stack project. You'll start by setting up ASP.NET Identity, which is a membership system for ASP.NET applications that provides functionality for user authentication, authorization, and management, including support for roles and claims. It gives your app built-in support for creating users, assigning roles, and logging people in, using built-in types like application user and IdentityDB context. It also handles password hashing and session tracking, so you don't have to build that from scratch. These pieces connect your database to your user management system and let you add roles and permissions later. Next, you'll build your authentication endpoints. These are API routes that handle user login and registration, typically issuing tokens upon successful authentication. You build one for signing up and one for signing in. Behind the scenes, they use Identity's User Manager and Sign-in Manager. When login succeeds, they return a secure JWT token that identifies the user. These tokens get passed along with future requests so the server knows who's making the call. You'll also set up authorization, which is part of the restricting process to certain parts of an application based on user roles or claim. You'll use authorization attributes to secure sensitive routes. Any method that updates or deletes data should be protected, so only logged-in users or users with specific roles can reach it. This helps prevent unauthorized changes and locks down key parts of your API. Once you set up authentication and authorization, you need a way to handle tokens. Token handling is the process of securely storing, using, and managing tokens on the client side to authenticate and authorize users. On the front end, you'll store the token in a browser storage and use it to access protected routes. Your Blazor UI will show different content depending on the user's login status and roles. This makes your interface dynamic and secure. These tokens are used in API requests to maintain user state. This helps your app recognize who's signed in and update that UI in real time based on that identity. Throughout the process, you'll use Microsoft Copilot to develop your endpoints, generate secure controller logic, and double-check for common security gaps. It can also help you persist session data and handle edge cases in your flow. Copilot makes it easier to focus on your logic while staying aligned with secure coding practices. By the end of this activity, your full-stack app will support user login, protect sensitive data, and update the UI based on role-based access. You have a secure foundation and a real authentication system. Let's get started. In this activity, you'll improve the performance of your application. You'll implement caching, optimize queries, and manage state in Blazor. You'll also use Microsoft Copilot to help support performance improvements. These strategies will help you reduce load on your database, respond faster to users, and track performance improvements as you go. They make your application more efficient and ready for real-world use. You'll start by adding in-memory caching to your API. Caching is a technique used to temporarily store frequently accessed data in memory to reduce the need for repeated database queries, and this improves response time. Instead of requerying the database for the same data, your app uses iMemory cache to store that data in memory and reuse it. This can dramatically improve response times. Once set up, caching reduces duplicate work and makes the app feel faster, especially for repeat visitors or unchanging data. To support caching, you'll also clean up your API queries. Query optimization is the process of improving the efficiency and performance of database queries by minimizing resource usage and execution time. You'll use tools like .asNodeTracking to skip unnecessary change tracking and .include to load related data efficiently. This will reduce extra work and make queries run faster and cleaner. These optimizations help prepare your API to serve large amounts of data with less strain. On the client side, you'll create a simple state management service. State management is the technique of managing user or application state across different components or pages, particularly in client-side applications like Blazor. You'll store user-specific data like role or ID in a shared service such as user session service. This enables different components to access that data without extra API calls. This makes your app feel more seamless, avoiding flickers or redundant loading when users move between views. But how do you know your changes are working? You'll add basic performance monitoring to test how long requests take and whether the cache is doing its job. You'll use tools like Stopwatch to measure request time and log cache hits and misses. This gives you real data to back up your improvements and shows you where you might still need to refine. And of course, you'll use Microsoft Copilot along the way. Whether you're adjusting caching logic or tuning a slow query, Copilot can help you spot inefficiencies and suggest improvements. Copilot can also review your code and highlight areas that could impact performance, so you can make improvements with confidence. By the end of this activity, your app will run faster, handle state more efficiently, and be one step closer to production readiness. You'll be able to measure your gains and keep building on them. Let's get started. In this final capstone activity, you'll bring everything together and refine your project. You'll validate your application from end to end, verifying caching and state behavior, refactor your code for clarity and efficiency, polish the user experience, and document your project. Copilot will help you refine your work so it's ready for peer review. This will help you refine your full stack application. You'll make sure it works as intended, looks polished, and is ready to share with others. First, you'll run through application validation. This means testing full user flows, including logging in, creating and editing data, checking role-based access, and confirming that each piece works together as expected. You'll simulate real-world user behavior from start to finish to ensure everything works as expected. Next, you'll check how caching and state perform under real interactions. You'll confirm user state updates correctly across components and verify that cache behavior is predictable and effective. This ensures your app stays fast and consistent as users navigate and interact. Then you'll move on to code refactoring. You'll review and refactor your code to reduce repeated logic, unclear code, or method naming. This is where Copilot shines, helping to clean up redundancy or streamline inefficient code. After that, you'll polish the user experience. This is your chance to adjust the layout and visual design for clarity. You'll also add placeholder content and helpful messages. And most importantly, you'll ensure mobile responsiveness. Finally, you'll prepare your project documentation. You'll summarize the app's features and purpose. You'll also document the architecture, how you use Copilot, and what could be added next. It's your chance to reflect on your work and show your thought process. By the end of this activity, your project will be functional, efficient, polished, and ready to submit. You've built a full stack application. Now it's time to validate, refine, and share it with confidence. Let's finish strong. Congratulations on completing the Full Stack Developer Capstone project, part of the Microsoft Full Stack Developer Professional Certificate. In this final course, you brought together all the skills you've built across the program to plan, create, and refine a full stack web application from the ground up. Let's take a moment to reflect on everything you've accomplished. You began by reviewing how to define and configure data models using Entity Framework Core. This includes designing classes to represent real-world data and connecting them to a database using DB context and migrations. You also explored how to build RESTful APIs. You discovered how to create controller endpoints that manage data through standard HTTP methods, enabling client applications to interact with the backend. You reviewed techniques for building reusable components in Blazor. These components form the building blocks of your user interface and help you keep your application organized, modular, and maintainable. Finally, you looked at how to implement authentication using ASP.NET Identity. You configured registration and login flows, returned tokens using authentication endpoints, and restricted access to secure routes based on user roles. After reviewing each concept, you reinforced your understanding through coach activities. These guided practice sessions allowed you to apply what you had learned step by step before moving on to the full Capstone build. Once your foundation was set, you transitioned into the Capstone project where you applied everything in a real development scenario. You scaffolded a full stack solution, created and connected API endpoints, and integrated your Blazor front end with the backend. You then worked to refine your application, adding caching and query optimization, setting up Blazor state management, and testing user flows from end to end. You used Microsoft Copilot to support code cleanup and optimization, then prepared your work for peer review with thoughtful documentation and final polish. You've now built a complete full stack application from the ground up. You've connected front-end and back-end systems, implemented secure authentication, optimized performance, and followed through on the entire development lifecycle. Congratulations again and best of luck as you continue your journey as a Microsoft full stack developer. Congratulations on completing the journey through a full stack development program. Throughout this comprehensive curriculum, you built the technical skills and problem-solving mindset needed to thrive in today's fast-paced software development landscape. Regardless of where you are in this journey, this work equips you with the confidence to create modern, scalable applications with Microsoft technologies and AI-enhanced workflows. We began with Foundations of Coding Full Stack, where you learned how to plan and structure development projects. You applied logical thinking and solved programming challenges. You designed algorithms, used control structures, and built modular, reusable code, supported throughout by Microsoft Copilot for coding and debugging assistance. In Introduction to Programming with C#, you set up .NET projects in Visual Studio Code and developed a strong grasp of programming essentials, including variables, loops, methods, and object-oriented concepts. You also worked with asynchronous programming and used Copilot to write and refine your C# code. Next, Introduction to Web Development taught you how to build responsive, accessible web pages using HTML, CSS, and JavaScript. You collaborated using GitHub and created a small interactive website with Copilot support. In Blazor Pages for front-end development, you used Blazor to build dynamic websites, working with components and data binding. You developed a complete Blazor project, managed app data, and used Copilot to enhance functionality and user experience. During back-end development with .NET, you created web APIs using ASP.NET Core, integrated Open API for documentation, and implemented optimized C# code with Copilot to ensure robust and seamless back-end performance. The Database Integration and Management module focused on using Entity Framework Core, EF Core, to work with relational databases. You set up databases, modeled data, and wrote SQL queries for data manipulation and performance, guided by Copilot's optimization suggestions. In full-stack integration, you combined your front-end and back-end skills. You built a full-stack environment, connected APIs, managed data flow, and relied on Copilot to support integration and project development. Through security and authentication, you learned how to secure applications using ASP.NET Identity and role-based access. You covered user registration, token-based authentication, encryption, and JSON Web Tokens, JWT, with Copilot helping you write secure, reliable code. In performance optimization and scalability, you focused on improving application performance through caching strategies, optimized queries, and load balancing. Copilot helped you fine-tune your code in database operations to support scalability and responsiveness. In data structures and algorithms, you explored efficient code methods for organizing and manipulating data. You implemented arrays, linked lists, trees, and algorithms for sorting and searching, using Copilot to optimize performance and solve practical back-end challenges. With deployment and DevOps, you deployed and managed applications using Azure Cloud Services. You set up CI/CD pipelines, automated deployment tasks, and monitored system performance, streamlining the entire process with Copilot's assistance. Finally, in the Capstone project, you brought everything together by building a comprehensive full-stack application. You integrated front-end and back-end components, optimized performance, and demonstrated your ability to manage real-world development workflows from start to finish. You've come a long way, from structuring your first coding projects to deploying secure, optimized full-stack applications. Along the way, you developed fluency in essential tools, frameworks, and languages, and you learned to leverage AI with Microsoft Copilot to work more efficiently and creatively. The skills you've gained open doors to roles in software engineering, web development, and cloud-based application design. You're now well prepared to take the next step in your professional journey, and we can't wait to see what you build next.